Bonding, in the context of electrical systems, refers to the establishment of an electrical connection between metal parts that are likely to become energized or are required to be grounded by the National Electrical Code, or NEC. When installing an isolated ground receptacle, maintaining proper bonding is crucial for safety and code compliance. The purpose of isolating the receptacle ground from the equipment ground is to provide a clean ground path, especially in sensitive electronic equipment. This reduces electrical noise and interference, which can be critical in applications such as healthcare. This maintains ground integrity, particularly if the primary equipment ground is compromised. However, isolating the ground does not eliminate the requirement for bonding. The metal housing of the receptacle needs to be effectively grounded, and this grounding path must extend to the raised cover. Since the raised cover typically lacks a dedicated grounding terminal, an alternative method must be employed to ensure proper bonding. A practical and code-compliant method for bonding the raised cover of an isolated ground receptacle involves using ring-tongue terminals and the length of appropriately sized grounding wire, such as number 12 American wire gauge, or OG. Here's a detailed step-by-step guide. Firstly, acquire the necessary materials, including 2 ring-tongue terminals suitable for the screw securing the receptacle to the cover and the metal box. Also, obtain a length of number 12 AWG grounding wire, which is commonly used for grounding purposes in electrical systems. Secondly, prepare the ring-tongue terminals. Attach one ring-tongue terminal to one of the screws that secures the receptacle to the raised cover. Ensure that the connection is tight and secure, providing a reliable electrical path. Thirdly, prepare the second ring-tongue terminal. Attach the other ring-tongue terminal to the metal box. This connection should also be tight and secure, establishing a solid electrical connection to the equipment ground. Fourthly, connect the 2 ring-tongue terminals. Use the length of number 12 AWG wire to connect the 2 ring-tongue terminals together. This wire serves as the bonding conductor, creating a continuous electrical path between the raised cover and the metal box. Ensure that the connections are properly tightened and that the wire is routed safely, avoiding any sharp bends or potential damage. Considerations for material selection are essential for ensuring long-term reliability and safety. Ring-tongue terminals should be constructed of a conductive material such as copper or brass and properly sized to fit the screws on the receptacle and the metal box. The number 12 AWG wire should be insulated and suitable for grounding purposes. Proper installation techniques are also essential for achieving effective bonding. When attaching the ring-tongue terminals to the screws, ensure that the contact surfaces are clean and free from corrosion. Tighten the screws securely to provide a lower resistance electrical path. Route the grounding wire carefully, avoiding sharp bends or potential damage. Secure the wire in place to prevent it from becoming loose or disconnected over time. It's crucial to verify the continuity of the grounding path after installation. Use a multimeter to measure the resistance between the raised cover and the metal box. The resistance should be very low, ideally close to 0 ohms, indicating a solid electrical connection. If the resistance is high, recheck the connections and wiring to identify and correct any issues. Regular inspection and maintenance of the grounding system are recommended to ensure its continued effectiveness. Check for any signs of corrosion, loose connections, or damaged wiring. Retighten screws and replace any components as needed to maintain the integrity of the grounding path. The NEC provides specific guidelines for grounding and bonding electrical systems. Adhering to these guidelines is essential for ensuring safety and code compliance. Consult the NEC for detailed requirements related to grounding and bonding isolated ground receptacles. Some important considerations when working with electrical systems include always energizing the circuit before working on any electrical components. Use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. Grounding and bonding are critical aspects of electrical safety. Properly grounding the raised cover of an isolated ground receptacle ensures that any fault current will safely return to the source, minimizing the risk of electric shock and equipment damage. Bonding creates a low impedance path for fault current, allowing overcurrent protection devices such as circuit breakers to quickly trip and de-energize the circuit. Furthermore, by following the steps outlined above and adhering to NEC guidelines, one can achieve a safe and code-compliant installation. Additionally, the use of appropriate materials, proper installation techniques, and regular maintenance are essential for ensuring the long-term effectiveness of the grounding system. Remember that electrical work can be dangerous, and it is always best to consult a qualified electrician if you have any doubts or concerns. A well-grounded electrical system is a safe electrical system, protecting both people and equipment from the hazards of electrical faults. This approach aligns with the requirements of the NEC, specifically regarding equipment grounding conductors and bonding jumpers, as well as meeting the intent of isolated grounding receptacle installations. In addition to the physical connection, it is equally important to verify the integrity of the ground both before and after energizing the circuit. Use a low resistance ohmmeter to confirm a low impedance path from the receptacle ground to the main grounding electrode conductor. Consider using a ground fault circuit interrupter, or GFCI, receptacle in conjunction with the isolated ground to provide an additional layer of protection. Be aware that isolated ground receptacles are typically identified by an orange triangle on their face. This serves as a visual indication that the receptacle has a dedicated grounding path separate from the equipment grounding system. When working in healthcare facilities, it is essential to follow the specific grounding requirements outlined in National Fire Protection Association, or NFPA 99, standard for healthcare facilities. This standard provides detailed guidance on grounding and bonding in patient care areas. Also, when selecting an appropriate wire gauge, the NEC typically requires a minimum of number 12 AWG for grounding conductors, but local codes of specific application requirements may necessitate a larger gauge wire. Consult with a qualified electrical inspector or engineer to determine the appropriate wire size for the specific installation. Furthermore, it's good to remember that when connecting ring terminals, ensure that the terminal is properly sized for the screw and that the screw is tightened to the manufacturer's recommended torque. Over-tightening or under-tightening can compromise the connection and reduce its effectiveness. Also, when working with metal boxes, be sure to remove any paint or corrosion from the contact surfaces before attaching the grounding conductor. This will ensure a good electrical connection and prevent future corrosion. It is good practice to label the isolated ground receptacle and the associated wiring to clearly identify its purpose and to prevent accidental disconnection or modification. Use a permanent marker or label maker to create clearer and concise labels. Regularly inspect the grounding system, especially in areas subject to moisture or vibration. Look for signs of corrosion, loose connections, or damaged wiring. Address any issues promptly to maintain the integrity of the grounding system. Remember to keep accurate records of all grounding system installations, inspections, and maintenance activities. This documentation can be helpful for troubleshooting and for demonstrating compliance with regulatory requirements. If the isolated ground receptacle is located in a hazardous location, such as a Class 1, Division 1 or Division 2 area, be sure to follow the specific grounding requirements for hazardous locations. These requirements are typically more stringent than those for non-hazardous locations. For example, in some cases, it may be necessary to use explosion-proof fittings and enclosures. And lastly, it is good to know that grounding and bonding are essential for preventing electrical shock, minimizing electrical noise, and protecting sensitive electronic equipment. By following the steps outlined above and adhering to NEC guidelines, one can achieve a safe and reliable electrical system. Remember to always consult with a qualified electrician if you have any doubts or concerns. In summary, bonding the raised cover of an isolated ground receptacle requires careful attention to detail and adherence to established electrical codes and standards. The use of ring-tongue terminals and a properly sized grounding conductor provide a reliable and effective means of establishing a low impedance path for fault current, ensuring the safety of personnel and equipment. Regular inspection and maintenance of the grounding system are essential for maintaining its long-term effectiveness.